Okay, tonight's homework is going to be over galaxies. I need you to watch the video, and just like all other flipped lessons, you do have the opportunity to stop it, to pause it, to rewind it, to replay it if you need to. Go ahead and fill out the top portion. Our topic objective for tonight is galaxies. And your essential question is describe the 3 types of galaxies. For this particular flip lesson, I'm not going to fill in the notes as you fill in the notes. This time you need to watch the video and you need to fill in the information that is available for you in all the open spots in your notes. I do want to point out to you the questions. 2 level 1, 1 level 2, and 1 level 3. These are questions that you need to make sure that you do. You also have the summary at the back, 2 to 3 sentence summary like always. Last time we did Cornell notes, so many of you didn't do this part and grades dropped pretty dramatically. Make sure you take care of the questions in the summary when you're done watching the video. These 3 portions right here of the notes that say draw an example of a spiral, an elliptical, and a regular galaxy do not count as questions. So make sure that you have that in place, but that you also add the questions later. Okay, so let's go ahead and get started. The universe is all space and the matter that space contains. It is an enormous, completely incredible idea that's hard for a lot of us to think about because it is everything and it's never ending. There is lots and lots of theories of how the universe began. A lot of times the science community looks at the Big Bang because there is a lot of evidence that helps to support the Big Bang theory. It's a theory, not a law. Law means it is truth. But this is one theory that the universe began with a giant explosion, and then from there all matter from the explosion formed the galaxies, the stars, and everything moved outwards from the point of that explosion. Yesterday I posted on Edmodo an article that dealt with some more evidence that helped to support the Big Bang, so you might want to check that out. A galaxy is a giant structure that contains billions of stars. The Milky Way, which is the galaxy that our solar system in, has billions of stars. And if you consider the billions of stars that are out there, then add those to the billions of galaxies that are out there, you're talking about a lot of stars. There are anywhere from 125 to 500 billion galaxies. If you look at approximately 100 billion stars per galaxy, you're talking about an enormous amount of stars. So our universe is quite large, and it includes a variety of galaxies that we're going to focus on. The 3 main types are based on their physical characteristics and what they look like. We have spiral galaxies, elliptical galaxies, and irregular galaxies. First of all, a spiral galaxy is characterized by a bulge at the center and spiral arms like a pinwheel. If you were to turn a pinwheel on its side, and you could see the little screws or the little knots that are in the middle that holds all the little pieces together, that would be like the bulge of our galaxy. And then when you blow it, those start to spin and they start to turn. Well, our galaxy also rotates, and the reason why it has this shape is because of the rotation of our galaxy around that center bulge. It has that spiral shape. Our solar system is in a spiral-shaped galaxy called the Milky Way, and we are actually right on the outskirts, right near the tip or the edge of one of those spiral arms. This is where you need to draw an example of what a spiral galaxy looks like. Make it quick, make it simple, draw it to the left of the notes. An elliptical galaxy is characterized by very bright centers and very little dust and gas. If you recall, a nebula is a spinning cloud of dust and gas. So if you do not have dust and gas in this galaxy, then you're dealing with a galaxy that has very old stars. It appears elongated or spherical, kind of like a smushed circle, if you will, and are basically just massive blobs of mainly old stars. So think about the life cycle of the stars that we talked about. Consider where the older stars are. You're dealing with your giants, you're dealing with supergiants, you're dealing with neutron stars. These are all very old stars. And the last type of galaxy is an irregular galaxy. It's a regular galaxy because, as its name indicates, it does not have a very regular shape. It does not look like a spiral. It does not look like a sphere. This is a galaxy that doesn't fit into any other class. So as the name indicates, it does have irregular shapes. You might want to take a second to pause the video so you can get your drawings of the three main types of galaxies. And then when you come back, we'll move on. Star systems. We talked a little bit about binary star systems when you guys were asking me questions about black holes. Star systems is a system where stars are members of groups of 2 or more stars. So if you were to think about our solar system, we have only one star. We have the sun. But if we were to be a part of a star system that had 2 stars, then as a planet, we would be rotating around 2 suns. Or if we were part of a triple star system, we would be rotating around 3 suns. So a binary star system, notice the word bi, means 2. So a binary star system is a star system with 2 stars, whereas a triple star system has 3 stars. And this is an example of a binary star system. Usually when dealing with binary star systems, you have 2 stars that revolve around each other, and they just continue to rotate around each other. Detecting a hidden star or planet. Sometimes we see this when dealing with the star systems. So when astronomers don't see it straight out using a telescope or a spectroscope, they can detect a hidden star or planet by observing its effect on the motion of the star that can be seen. So if there is a star that's hiding behind another one, what will be seen then is a wobbling. And the observed star that can be seen will wobble or move back and forth, and it will be due to the gravity pull from the star that's behind it, or the planet that is behind it. Everything that has mass has gravity, and those that have greater mass has a greater gravity pull on other objects. So when a star in front will wobble just a little bit, astronomers see that, and they know stars aren't going to move by themselves. So they know that there is a hidden planet or a hidden star behind it, and then as they continue to watch the stars move and watch the stars, if they do revolve around each other, then they are able to see that extra star there. And then what you see here is just a picture that has been taken of the Milky Way, and you can see there's billions of stars. You can see some look brighter than others. You can see the different colors of the stars. It's a giant universe, and you know, as we focused on stars and as we focus on the galaxies, it's quite interesting to think about our tiny, teeny, weeny little spot here on Earth and compare it to this enormous universe that we do have. That takes care of the video. Please make sure that you take care of the questions and the summary. Tomorrow we'll be doing an activity where we're going to be classifying and looking at various galaxies. It's very important you have this completed. It will be graded. My favorite color is green, and I will see you tomorrow.